In section 3.6 here, we look at still factoring trinomials, polynomials, but this time you'll notice that instead of just having these two numbers, this coefficient and this constant, we're now going to have another number out in front of this x squared term. Now really there was always a number in front of any of these, x squared plus 5x plus 6. There's a number here in front of this x squared term of a 1. We just never write it. So there's always been a number there, but now we're going to have a number that's not 1. And the steps are a little bit different in factoring these. So what we do need to remember though, when we were factoring a polynomial in this form, x squared plus bx plus c, we used a table where we thought about factors that allowed us to look at b and c, c and b. We look for two numbers that multiply together to give c, but those same two numbers add together to give b. Right? So here's our example that we're going to look at right now, just to refresh our memory. X squared minus 9x plus 8. We're looking for two numbers that with a product of 8 and a sum of 9. So if we're looking for a product of 8, we think about the factors of 8. Factors of 8 are 1, 2, 4, and 8. And then of course combinations of positive and negative values. So if we look at the factors of 8, 1 and 8, if they're both positive, our product is 8, the right value that we're looking for, but our sum is positive 9, not what we're looking for. So we try negative 1, negative 8. That gives us our proper product of positive 8, except our sum is negative 9, which is actually what we're looking for. But we'll just quickly do the other ones. 2 and 4, positive 2, positive 4, product is 8, but our sum is 6. And then negative 2, negative 4, our product is 8, and our sum is negative 6. So we know that it's not going to be these three. We know that it is going to be this combination. It gives us these values. So a combination of negative 1 and negative 8. And we simply write our binomial bracket with x at the front, and then minus 1 and minus 8. And that's how we would factor that. Things change though when we have a value in front of that x squared term. It says notice that the coefficient of the squared term has always been 1. So up till now that's all we've been doing. Well, what happens if a is not equal to 1? What happens if that value in front of that x squared term is not just a 1? So in this case, 3x squared plus 4x plus 1, you can see that this obviously is not a 1, it's a 3. Well, what do we do in this instance? Or with questions like this? We followed a similar pattern, similar process, and I've noted and listed it out over here. We're going to use something called decomposition. Okay? Make sure that you reorder the question into this order, otherwise it's going to mess you up a little bit. Alright, so I rearrange my equation so that it's ax squared plus bx plus c, so x squared turned to the constant, and rearrange it. It'll just make things easier. Now we're going to look for two numbers that when multiplied together, it's going to give us a value of a times c, so not just c, but a times c, and that's what ac here is, a times c, but they add together still to give b. They still add together to give b. Okay, so if we look at our example, 3x squared plus 4x plus 1, I'm going to look for two numbers that multiply together to give us 3 times 1, which is a times c, which is equal to 3. So two numbers that multiply together to give 3, but those same two numbers, those same two numbers are going to add together to give us 4. Well, luckily, there's only one set of factors for 3, and those are, well, 1 and 3. Two numbers that multiply together to give 3. It's got to be 1 and 3. There's no other options. And in this case, positive 1, positive 3 give us that sum of 4. So 1, I should write this in the order that we do them in. Okay, I look for two numbers that multiply together to give 3, but those same two numbers add together to give 4, And why is it 3? Well, 3 comes from a times c. Those two numbers are going to be 1 and 3, both positive, 1 and 3. So that's the same first step that we would do before, except now we incorporate this coefficient in the calculation. Our second step, this is where the process changes. Our second step is we want to use something called decomposition. Well, decomposition is a fancy word for breaking down. Okay? When we decompose things, when things decompose, they break down. So what we want to do is decompose that bx term, or decompose that middle term. Decompose the x term using the two integers that we just found. So here, we know that my numbers, or we know that the numbers are 1 and 3. So I take this 3x squared plus 4x plus 1 and I change it. I go 3x squared plus 1x plus 3x plus 1. I decompose, I split this middle term up into two different terms using the integers that we just found, 1 and 3. Okay, so I've not changed the question, I've just made it bigger or longer. Okay, but if I simplified that, I would still get 3x squared plus 4x plus 1. So I've decomposed it. That's the second step. Okay. Next, group the first two terms and find a greatest common factor. Whoops, first two terms and find a factor. Group the last two terms and find a factor. All right, group the first two terms, find a factor. Group the last two terms, find a factor. Okay. What we used to call this, way back in the day, back in my day, we used to call this t factoring, because I could very simply just draw a t. Okay. You may still see this some places, but this is also referred to as factor by grouping. So I group these first two terms, 1, 2, those two terms, 3x squared plus 1x. And I look at that, and I go way back to what we learned in section 3.1 and 3.2, and I find a greatest common factor. What's the greatest common factor between 3x squared and 1x? Well, it's just x. Okay? X goes into both of them. Or I could say, you know what, it's 1x, but I never have to write the 1, so I'm not even going to write it. So it's x. If I factored if I factored x out of 3x squared, out of this term, what would I be left with? I would be left with 3x. Okay, and you can think to yourself, well, if I expanded that, x times 3x has got to give me 3x squared, right? So I know that's right. Then I look at the second part, or the second term. If I factor out an x from 1x, what am I left with? And you should always be left with at least a 1, right? 1 times x is 1x. So that's factored. I've taken a greatest common factor out of my first two terms. I look at my second two terms, or my second group. What is the greatest common factor between 3x and 1? Well, there is nothing except 1. And in this case, I actually take out a 1. So I factor out a 1. If this is a positive or a plus here, this also becomes plus. Take out a plus or a positive 1. What am I left with? Well, it doesn't change, 3x plus 1. Now, lo and behold, look what happens here. This and this end up being the same, right? So this, 3x plus 1, is one of my factors. My other factor comes from what I factored out, x and a plus 1. X and plus 1. Okay. So remember back when we were talking about using distributive property and splitting up a binomial times a binomial using distributive property? Well, that's essentially what we were doing when we were going like this. If I'm multiplying x plus 1 times 3x plus 1, it's going to be x times 3x plus 1 times 3x plus 1. And then 1 times 3x plus 1 times 3x plus 1. So really it's working backwards. So these are my factors for the polynomial 3x squared plus 4x plus 1, following these steps. Okay. So step 1, find our numbers, our integers, a times c multiply together to give a times c, add together to give b. Once I have those numbers, as I decompose them, decompose that middle term into them, I factor a greatest common factor out of the first two terms, I factor a greatest common factor out of the third and fourth term, and then from here, the common factor is one of our factors. The common factor is one of our factors, the 3x plus 1, and then I'm left with my other factor. And like it says right here, I could very quickly check this by expanding. X plus 1 times 3x plus 1, FOIL, first, outside, inside, last, gives me 3x squared plus x plus 3x plus 1, 3x squared plus 4x plus 1. Done.